Hello. In this unit, we are going to talk about managing pool of resources. And we already covered a little bit of this type of material in week 2 when we talked about Anton, or even actually singleton, because in the case of singleton, the class resource manage its own instance. Then we extended this to the Anton, and we talked about managing bunch of instances of this class by the class itself. Here we are going to take this one step further. And to have this general discussion, first let's look at this particular slide here when we are talking about constraints to consider when we look at this problem. There are basically three major constraints. One, there's the question about the nature of these resources. Are they homogeneous or are they heterogeneous? Now, we can obviously have an answer yes or no to this particular question. The second question we have, are the resources shareable? And again, they either are or they are not. And what shareable means is that particular resource, particular object can be in the hands of more than one customer if it's shareable, and that's okay. If it's non-shareable, it requires mutual exclusion of access to this object, so it means that if one customer is using the resource, then no one else should have access to it. And the last constraint is about resources being reusable. And again, here we can have either resources which are reusable and some are not. Now, let's actually tackle the last issue first, and the reusable resources. The claim is that for the rest of our discussion, we will assume that our resources are reusable. Because if resources are not reusable, it means it translates to being disposable. So, yes, we might issue the resource to someone, but when someone is done with this resource, basically, they will drop it and destroy it. So it makes the management is pretty much trivial because it's reduced only to the function of giving things out. So in the rest of this discussion, we assume that the resources we are going to manage are reusable. For that reason, there are only two things to consider, namely, are they or are they not homogeneous? And the second, are they or are they not shareable? And this brings us to this particular slide when we break everything up to these quadrants, which represent different cases. And as you can see, case one talks about the resources which are homogeneous and shareable. Case 2 is homogeneous and non-shareable, etc. So you'll cover them in that particular order. So let's look at case 1. Case 1 is the resources are homogeneous and they are shareable. So what this means is that the client simply comes in and says, well, I would like to have one of those things which you provide, and there's no need to simply say what the client wants, because just by the virtue of coming to me, I only have one thing, all the resources are the same or homogeneous. So if you come and you say, get instance, well, that's exactly what you are going to get. And if we look at the shareable, it means that this resource can be given to multiple clients without worrying about compromising the integrity of the resource. Now, this particular case pretty much is covered by the Anton pattern, which we covered last week, week 2. So we are not going to spend any time on that case. Case number 2 is more challenging. It addresses the homogeneous but non-shareable resources. So again, going back to our definitions, all the resources are of the same nature, so it's no big deal. You come and I know exactly what you need, what you want. But we have to guarantee that only one client has a resource at one particular time. Now, this raises a major question because, as you remember, we said all our resources are reusable. So it means the fact that someone had this in their hands and used it does not mean that what we do not need it back. So the question is, how do we reclaim a resource which was assigned to some client? And reason for this is that we want to reassign it to someone else. So now we have to consider case two in probably two versions. The first is somewhat naive version, and we will see why it's naive very shortly, that a client acquires a resource and the client returns the resource. So it means, you check it out and then you give it back and everything is okay. So the first thing is the client calls some method, or they kind of know what's going to happen here from end-on discussion. So they call resource class and say, well, I would like to have a reference to a resource, and then it calls some other method and say, here I'm returning the resource, and it provides a reference to that resource. And obviously, if we manage these resources by comparing references of, oh, this is what's going to be returned, because we never lose a reference to the resource which was given to any client. So let's look at the picture. Obviously, here we have a client, and here is our class resource. This group represents objects of the class resource. So when you look at this, this is very similar to our discussion about entering pattern. So here is our get instance function. We are going to see the code in a moment, but this is the get instance function, and here's return instance function. So the client calls right here and say, could they have one of these things you're managing? The class resource returns to the client a reference to the object selected right here. So this represents the reference client has to that particular resource. And then the client calls return instance, providing this reference. And as you can see, because the class always holds reference to all of these resources, retains reference to all the resources, and say, let me compare the red one with one of the black ones. Oh, here is the match. So this means this resource is being returned. So just for the sake of discussion, we kind of assume that obviously this is just an illustration of how it could be implemented, that we have two arrays. One holds references to resources, the other one is just simply a Boolean array, which, if it holds true, then this resource is available. So in this particular case, because we know that this resource here has been allocated to a client, as we can see in the picture, then this will hold false. We did not draw the lines from this array to all the resources just to prevent this picture to be cluttered, but you can imagine that all of these references point to the resources which we manage. So here is some peek at the code, and so here we have two arrays. As you can see, is no big deal. We have to make sure that both of these arrays obviously have to be allocated and have to be initialized, and initial values for all elements in the array free are true because all the resources are free when we first launch that operation. And here we have the two methods, get instance and return instance. Obviously they are static because it will be called through the class. Someone's client is going to say resource as a class dot and get instance, and it will call resource dot a return instance, and we know this from our discussion already about the intern. And right here is some little sketch of the code, how this would happen. So when we allocate the resource, we might have some little question, how do I select the resource to be given to the client? They're all homogeneous, but there might be some little things. For example, I would like to be not to send all requests, not to give one resource to all the clients forever, because why do I have the other ones? So maybe I do this in some round-robin fashion or based on some other characteristics, maybe in a random fashion. I choose an I, and then this is the value which I selected. There are a few problems with this approach. I already said something about choosing the strategy for assigning resource to the client, so this will be either random, round-robin, you name it. The big problem is with returning a resource. Basically, there is no way we can trust the client to return the resource. One problem is that if the client, and we can go a couple of slides back, if the client holds a reference to our resource, there's nothing we can do about the client calling the return instance, providing us with this reference, but actually never releasing this reference right here. So it means the client retains the reference to the object, which is our resource, but it told us that this resource is released. So now we give it to another client, and the old client, this one, who kept a copy of the reference, and the new client are both using this resource, and this violates the constraints of resources being non-shareable. Now, that's not the end of the story, because it's not only this, but the client, by having this reference, it can copy this reference and share it with some other entities. So it means it's like a phone number which someone takes and writes on the wall in the office, post on the bulletin board and on their web page, and now says, okay, I'm returning to you this resource, which whatever is behind this phone number, and obviously everyone can use this number and call the resource. So this is not going to work. Okay. The second problem is that even if the client is disciplined, because what may happen that this client is a software we write on our own. So it means we will never do such things. So when we say, oh, I'm returning this resource, the next line, I'm going to simply say, okay, just take this reference equal to null, and I do not copy these references, etc. This still might not solve the whole problem, because the other part is that bad things can happen to the client. So, for example, in the middle of doing something between the time when a resource was acquired and the time when the resource is supposed to be released, there's some unhandled exception, and the client simply terminates. So what happens? This resource will never be returned. So in this situation, what we will have a degradation of services, because some of these resources which are never returned, they always are labeled busy. And at some point, we have nothing else to give. So this is not a good strategy. So what can we do? What we have to do is we have to take into our own hands, as the entity which manages the resources, the process of reclaiming them. So it means, okay, client calls and can get a resource, but reclaiming it will not be up to the client. Here are some observations. First of all, client is not known to the resource class. So class does not know who the client is and how to reach the client. So the only way to reclaim the resource is through an object which is known to the resource class. So this will be some object which will be issued by the resource management, but the access to that object will be retained by the resource management class. So we will call this object a proxy. So client will not get access directly to the resource, but will get an access to the resource through a proxy. We will explore what this actually means. The next problem, once we make this decision, the next consequence of this decision is that for a client, this arrangement should basically be transparent. So it means client should not feel that it has to interact with a proxy differently than it would interact, than how it would interact with the resource itself. And this is going to be facilitated through the process of both the resource and the proxy implementing the same interface. And we will call this resource interface. You're going to see how it plays in a second when we look at the picture and some code. So here is our picture. Now, some things which look familiar, namely get instance, did not change because the arrangement is still the same. The client comes and asks for the resource. These are our objects. This is the class. The difference is this particular object, because this object is our proxy object. And please note that the client does not have direct access to the resource object. It has access to the proxy, and then proxy has access to the object. Please also note that we do not simply say, well, resource busy versus not busy, but we use this to hold a reference to the proxy. So proxy is like a contract. So when the resource is assigned to someone, this particular corresponding value in this other array holds a reference to that proxy, to that contract. So here we go. That's how it looks. We have to also notice that there is a new method it's called here release resource, and this method is a method of a proxy which will be used by the class resource, which manages all of its instances, to simply cancel this contract to access this resource by that client. We will probably get back to this picture. Again, please note that this object is known to the proxy by the name myResource, and we will see this in the code. So here we have to define a few things. The first thing which we have to define is this interface we mentioned. So a public interface, a resource interface. What this defines is all the business method of the resource. So this defines what the resource is. So if, for example, this resource class is a stack, then this particular interface would include the methods push and pop and full and empty and whatever other methods you may have for a stack. And all these methods, obviously, as an interface, it would be abstract. So now, here we go to the class resource. And class resource implements resource interface, and right here at the bottom, we simply say that we will have implementation of all these methods. So if this was a stack, then here we will have implementation of push and pop, etc., etc. But what we show here is a portion which is related to how we manage the resources. So please note that this class has a private static, these two. We do this through arrays, but this is just to illustrate in a simple manner how this could be implemented. We have the array contracts, and this is array of proxies. And we have, like before, the array res, which is the array of resources. So again, all the contracts, all the proxies are initialized to null to start with because there are no contracts for any of my resources. Now we have a public static resource get instance. This is pretty much similar to what we had before. The only difference is that now we are trying to find an I for which, there is no contract. Okay, and then we return this resource wrapped in a proxy. We are going to see how this happens. Okay, so we create a proxy, pass the resource to that proxy, and then we return it to the client. We also have to make sure here that what was somewhat forgotten here, but has to happen is that obviously we have to say contracts at I take equal this new proxy. So we have to retain the value of reference to that proxy. When it comes to reclaiming an instance, we find such an I. This will be the victim. So such I that such I which corresponds to the resource we want to reclaim. Okay. So in this array, we choose a victim. We say, okay, we want this one back. How this is done? Well, it depends on the strategy. This could be combined maybe with timestamps where we not only have the contracts, but we also have another, for example, parallel array to this, which has the timestamps when the contracts were issued, and we cancel the contract which is the oldest, so it means someone had the object the longest. We can choose it at random, etc., etc. Now, so what this does is when we choose who the victim is going to be, then we simply say contracts I, this is access to our proxy, we call release resource. And then contracts I take equal null. Okay. So now, how this is going to work on the proxy side. So the proxy side, remember, holds a reference to the resource. And when I make a proxy, I pass a resource, and I basically proxy records the reference to that resource right here. When I call a release resource, I do my resource take equal null. So the proxy cuts the access. Sorry for that. Proxy cuts the access to the resource, and the consequences of this will be evident in a moment. So now let's look at the implementation of all the business methods of the resource interface. So just to remind you, if this is a stack, this is push, pop, etc. So let us just assume that there is a method which looks like this. It returns something of type A and has named doit, and it has a parameter passed to it of the type B. A and B are some classes. It does not really matter what kind of classes. So I have public A doit B. Here how it works. If my resource right here is not equal to null, so it means I am a valid proxy, I simply call my resource through the same method. Please remember they both implement the same interface. So if doit is part of this interface, my resource also has doit. But the difference is that in the resource, do it has specific implementation, which does what it was meant to do. Here, our do it is simply a pass-through method. So obviously we can have a situation when nothing is returned, then basically the call is without return and says my resource do it. We could have a situation when there are no parameters, but something is returned. But this is a graduate course. You can figure out all the potential other options. I'm showing you the one which is both a return type and parameters. Now, what happens if it is null? I can do two things. I can do nothing in the root, which means that this null, the exception about null parameter, null reference would be passed to the client who calls do it, or I could be nicer and create a new exception, which I will name proxy not valid or access denied or something like this, and else throw that new exception here at the client, so client can write some meaningful exception handling, which will say, okay, I'm going to use this resource properly until I get an exception that my contract is no longer valid, etc. Now, we are moving to case 3 and 4. What these two cases share is that resources are non-homogeneous. Now, this changes the game quite a bit. Now, there are three possible scenarios in this situation of resources being non-homogeneous, which means heterogeneous. They can be heterogeneous, they can be distinguishable, they can be different. Even so, they are of the same type and the same subtype. So it means we have the class and we don't have any subclassing. So let's say we have a class stack. And all resources are stacks. But to a client, the state of an object makes a difference. So for example, the client wants a stack which still has 50% at least of its capacity free. So the state of the object which I'm requesting would be in the discussion. So objects can be different by the virtue of their state. So this is heterogeneous by state. I could think about a pool of printers, and I have a bigger job to print. And all printers are the same, but they have different amount of paper in them available. And I want a printer which has at least specific amount of paper in the cartridge or in the drawer because I'm printing a bigger job. So I'm not requesting specific printer. The printers are not color versus black. It's simply the state of the printer. But this is one here. The second one is different, that all the resources are the same type, but they are not necessarily the same subtype. So it means the subclass, so I have a notion of a printer. Let's go back to our printers. And I have color printers and I have black and white printers. Now I'm obviously going to this class printer, which is a type, but I'm interested in specific subtype of an object. And that's what makes this object heterogeneous to me. So it means I distinguish them by the subtype. The third category is, and you notice this is a different color here, kind of faded, that resources are not of the same class, not of the same type. So this would be like apples and oranges. Well, even this is a discussion because they're all fruits, but let us assume that they are, I don't know, um, cars and apples. Uh, the validity of this particular case here is questionable because why would you manage them in the same pool through the same management system if they are of different classes? So to some extent, our case falls apart here because the whole idea was that the class by itself manages its instances. But all of a sudden, we have two separate classes. We have a class car and we have a class apple. So this all breaks to two separate cases like the one we are considering. So you either go and try to get a car or you either go and get an apple, and these two things are managed separately. So for this reason, we will not consider the case C. We simply say it's of no concern to us. We will only look at A and B. Here is what's common to A and B. Please remember, we are talking about case 3 and 4, which means resources are non-homogeneous. But 3 and 4, the difference is shareable, non-shareable. So one thing which is obvious, if resources are non-homogeneous, that customers, through the parameter or parameters of the method getInstance, has to indicate what kind of resource it requests. So the customer simply has something to say, what they want. In a homogeneous case, they just came and say, I want something, and this basically made it obvious for the class what they came from. Here, this is not the case. The second issue is that class resource has to be aware of different kinds of resources. So it means the class by itself has to say, okay, I have this and this subtype of resource if this is based on subclass. So it means, for example, it has to be aware that some printers are color, some are just black and white. If this is the case B. If it's case A, this is just a state. I still have to know, to be able to distinguish, for example, now in a case when we talk about the amount of paper in the printer, how much paper is in each printer. So what is the state of all these resource objects which I have, because we are coming to this point. In making a decision, how am I going to match the request of the client, who through the parameter says what they want, with the resource or resources which are under my control or under my management. In this process, I have to match this heterogeneous type of constraint between the request and the supply of objects I have. Okay, so now, as this is a graduate course, this is going to be exercise for you. We look at case 3. Case 3 is non-homogeneous and shareable resources. Non-homogeneous and shareable. Now, this case will be a variation of Anton pattern. Anton pattern, remember, this was like shareable resource. So it means I give it to you and I don't care how many people have the same thing, am I right? Now they are non-homogeneous. In Anton pattern, they were homogeneous. So the question which I pose to you, and this will be on the discussion board, your assignment, what is the difference if the resources, in case 3, if the resources are A heterogeneous versus B heterogeneous? Now the same thing is going to apply to case number 4. In case number 4, we deal with non-homogeneous resources, but they are non-shareable. So this is a variation on case 2. Again, I will pose a question to you. What is the difference if resources are A, heterogeneous versus B, heterogeneous. And this is going to be subject of our discussion on the bulletin board. That's about it. Thank you very much.